let's try H4 now. H4 says to factor each perfect square trinomial. And if you don't understand what a perfect square trinomial is, that is okay. So number 4, we have this one. Did anyone use a different method? Okay, so if you don't use a different method, is it going to be super difficult? Ashley, can you back up? Let's see how difficult this would be if we don't have a watch. Still possible. You can do it. A times C. $1,600. And then my B value is 80. Two numbers that multiply to be 1,600 and add to be 80. Yeah. 40 and 40. Now, let's say you didn't get that right. I only have a couple of contracts left. I still have a couple of these to check out. If you press Y equals, type in that number, 1,600, divided by X. If I put second table, 1,600 divided by 1 is 1,600. 1,600 divided by 40 is 40. So it actually can confirm. All the decimals means it has a remainder. So this can help us quickly find them, right? So if I put in there 40 and 40, splitting an X. Now I have to do the box because A value is greater than 1. So I have to use this. I have to use the box. So I put the first term there, last term there. Class, what's the greatest common factor? That's a 40. 5x. How about this direction? Yep. How about this direction? Remember, something times 5x equals 40x. 8. And how about here? 8. 8 times 8 is 64. So that gives me 5x plus 8, 5x plus 8. And if you have two of them, what is it called? 5x plus 8 squared. So here in purple, this would be my answer. So this actually explains what a perfect square trinomial is. It's a square, and those on the outside are essentially the same. Remember, this is a visual of what a perfect square is. 9. 9 is a perfect square, right? Why? Because each of the sides are 3 and 3. Now, did anyone do chunking? Good. I saw a couple of students do this, so let's try it. I need to put in the same number in this parentheses. With your partner, think about what goes in the parentheses and what goes here on the outside of the parentheses. Tell your partner. Ready, set, go. Class, what number goes there? 5x. Because 5x squared gives us 25x. And 5x times what? 16. 64 is the same. Your substitution is 5x. You're going to get box squared plus 16 plus box plus 64. And that'll give you box plus 8, box plus 8. And then you just do your substitution of 5x. Does that make sense? So chunking would have been really good if you recognized that it did work in that problem. Good job.